My today's topic for discussion is vapor pressure and Raoult's law. Now the question arises, what is the meaning of vapor pressure? So to explain that, I have taken three images. Image number one, that is liquid toluene. Image number two, that is toluene plus benzene, and image number three, that is pure benzene. Now for the image number one, the first picture in here shows that if we take only liquid toluene, some amount of liquid will evaporate and they will create pressure on the surface of toluene, and this pressure is known as vapor pressure. Similarly, in case of benzene component, liquid benzene, when it evaporates, the vapors of benzene create some kind of pressure on the surface of benzene, again which is known as vapor pressure. But since there is only one component, we say this is vapor pressure of pure component. In this case I can say P naught toluene, so P naught T toluene, and here I can say P naught benzene, or we can also call them A component or B component. So if my toluene is A component and benzene B component. And in the second image, I have taken example of both toluene and benzene mixed together. Now, if both the volatile miscible liquids, so both are volatile and both can be mixed together and both do not react with each other. So volatile miscible non-reactive liquids, when they are mixed together, obviously benzene will also evaporate and toluene will also evaporate. So we see both the components. But if in the liquid phase benzene is more, in the vapor phase also you will find more benzene. If in the liquid phase toluene is more, then in the vapor phase obviously you will find more of toluene component. Here in this example we have more of benzene in the liquid phase, that is blue dots. That is why in the vapor phase we can find out more of the blue dots. But the pressure exerted will be due to both benzene and as well as toluene. So we call it partial pressure. So partial pressure of one component, let me say A component, is that of our toluene, and partial pressure of B component is that of our benzene. Now the total pressure in this case, so pressure total will be equal to partial pressure of A component plus partial pressure of B component. Now let us understand what is the meaning of partial pressure over here. Now in this case, in the second example, so second example will help us understand what is the meaning of Raoult's law. In case of second example, where both toluene and benzene, miscible liquids which can be mixed together, they are present. Now partial pressure of A component, let me assume this benzene is A component. So benzene is A component and let toluene be component B. So partial pressure of A component is directly proportional to mole fraction of A component. What is the meaning of mole fraction of A component? So in the liquid phase, the mole fraction of A component will determine how many amount of vapor they are going up in vapor phase. So partial pressure of A component is directly proportional to XA, mole fraction of A. So if I remove proportionality sign, I will say constant P naught. What is this P naught? P naught of A component. So into XA as it is. Similarly, partial pressure of B component is equal to, that means directly proportional to mole fraction of B component. So in the proportional, if we remove the proportionality sign, we put here P naught B, that is constant for proportionality. So partial pressure of A is P naught A into XA. Partial pressure of B is P naught B into XB. That means the total pressure. So total pressure, now this is Raoult's law. So what did Raoult say? So Raoult said that when we mix two miscible liquids, the total pressure, so P total is equal to P naught A into XA plus P naught B into XB. So partial pressure of A component plus partial pressure of B component. Let's understand Raoult's law graphically. So Raoult's law state that partial pressure of A component is directly proportional to mole fraction of A, and partial pressure of B component is directly proportional to mole fraction of B. Now I have taken a graph where x axis represent mole fraction and y axis represent partial pressure, vapor pressure. Now at this point XA is 1, that means only A component is present. That is why the pressure exerted is only due to A component. At this point only B component is there. That means the pressure exerted is only due to B component. But as we are moving from left to right, we are going from XA1 to XA0 and XB is increasing. That means on going from left to right, B component is increasing. That means this line, straight line, will give us the partial pressure of B component at any point. So this represent increase of partial pressure of B till we get only B component, that is PB naught. From right to left, A component is 0 and we are increasing A component and decreasing B component. That means we are increasing A component. So this line will give us partial pressure of A till we get only A component left, which will give us finally only A component partial pressure on the left hand side of Y axis. Right. Now let us see any vertical line, from here, any vertical line. Now what does this line represent? So this point on this line, so all the points on this line represent partial pressure of B. So we take at any point partial pressure of B. So let me assume this much is X and this much is Y. So distance from this point to this point is X and this distance is Y. So that means partial pressure. So what we did assume, we assumed that we took a line, horizontal line. So we assumed that this is X and this is Y and this is PB. So PB equals to distance X plus distance Y, and this much is X, PA. So PA is X, but X plus Y is already PB. So this much is already PB and we have to protrude X little bit more to get PA also. So PA plus PB is equal to X plus Y. So X plus Y we already had over here. Now we are protruding X little bit more and it will reach this point. That means this point will be our P total, right? And if we join P naught A to P naught B, so any point on this line will be P total on that point. So that represents P total. One more thing we have to understand, that if we take only vapor phase, here for only vapor phase, let me assume mole fraction of benzene is YB and mole fraction of toluene, let it be YA. In liquid phase, mole fraction of toluene is XA and mole fraction of benzene is XB. Now, Raoult law is applicable to mole fraction of liquids, but if we have to consider only gaseous phase without in equilibrium with liquid, the law applicable here will be Dalton's law. So what did Dalton say? That mole fraction of any component in gaseous phase is equal to partial pressure of that particular gas divided by total pressure in gaseous phase. Similarly, YB will also become partial pressure of B component in gaseous phase divided by total pressure of gas in vapor phase. Moreover, Raoult law is applicable only to those solutions which are ideal in nature. What is the meaning of ideal solution? A solution of toluene and benzene vapor liquid equilibrium is ideal because, let me assume toluene be A component and benzene be B component, because AA interaction before mixing and BB interaction before mixing is equal to AB interaction after mixing. That means whatever bonds were present, whatever bond strength was present in AA or BB, similar bond strength is present now in between AB. That is rule number 1. Rule number 2 is delta H mixing is 0. That means this process of dissolution of two miscible liquids is neither exothermic nor endothermic. Number 3, delta V mixing is also 0. That means if we mix 100 ml of toluene in 200 ml of benzene, total mixture will be 300 ml. Neither there will be increase. So 100 plus 200 should be 300. So it cannot be 400. It cannot be more than 300. It cannot be less than 300. That means there is neither increase of volume of mixture nor decrease of volume. Such solutions are known as ideal solutions. And if we mix two miscible non-reacting liquids which are ideal in nature, for example toluene and benzene, it will always obey Raoult's law. Let's try to solve this question on Raoult's law. An aqueous solution containing 28% weight of liquid, so 28% weight of liquid of molecular weight 140. So we do not know whether whatever is the liquid, but yes, the solute has molar mass as 140, has vapor pressure. So total vapor pressure is mentioned 160 mm at 37 degrees Celsius. Find the vapor pressure of pure liquid A, as given the vapor pressure of water at 37 degrees Celsius is 150. So now two liquids A and B are mixed together. One is water and one is unknown. So we will apply pressure total is equal to P naught A into XA plus P naught B into XB. Now pressure total is given. Then what is given is 28% by weight. So solute component, so solute is mentioned 28%, that means 28 grams. Then what will be the solvent? Solvent will be, that is water, that is 100 minus 28. So what will be 100 minus 28? 100 minus 28 will be 72. So solute 28%, 28 gram out of 100. Solvent will be 72 grams. Now we have to find out number of moles of A component, that is solute component. 28 is the solute, molar mass given is 140. This comes out to be 0.2. Then the number of moles of B component, that is number of moles of B component, that is 72 gram is B component, and molar mass is 18 as it is water. So this comes out to be 4. So 0.2 and 4. Now we can easily find out the mole fraction of A component. So mole fraction of A component is equal to 0.2 divided by 4. Total number of moles 4 plus 0.2, that is 4.2. So this comes out to be 0.048. So 0.048. And mole fraction of B component is 1 minus 0.048. That is equal to 1 minus 0.048 is equal to 0.9952. So we have XA, we have XB, we have pressure total mentioned. Then we have vapor pressure of water also, that is 150. So everything is given, only we have to find out P naught A. So we can apply this formula. P total is 160, which is equal to P naught A, which we have to find out solutes P naught. And mole fraction of A component, we just found out mole fraction of A component is 0.048, that is solute 0.048, plus P naught B is mentioned in the question itself as 150 into mole fraction of water, that is 0.952. So when we solve this, P naught A, so on solving this, P naught A comes out to be 358.3 mm.